Hey everybody, here, check out this video here. Here's the solutions for the second final exam review. Okay, let's take a look at this. I did change the equation to just be plain old x squared to make this a little bit clearer. So if the function is just x squared, then 5x squared minus 1 is just a vertical stretch by a factor of 5 and shifting it down 1 unit. The next one, part B, x minus 5 squared plus 4 is a shift to the right, a shift to the right of 5 because of that x minus 5, and then up 4 for the plus 4. So minus 1 was shifting down, plus 4 is shifting up, both outside of the parentheses for x. Just like this one, x squared plus 2 is just a simple shift of up 2 units. Okay, let's go through the number 2 here. You're just evaluating these functions for different inputs. So you put a negative 5 into g, you get negative 5 out. Just you can do the arithmetic there. If you take g of 0, 2 times 0 is 0, plus 5 means 5. So g of 0 equals 5, and then f of 5 means 1 over 5 plus 7. So that's 1 over 7. I'm sorry, 1 over 5 plus 2. That equals 1 over 7. G of f of x means you're going to take f of x and put it in there for x into the g function. So 2 times 1 over x plus 2 plus 5. And that just equals 2 over x plus 2 plus 5. You just multiply the 1 over x plus 2 times 2. That just means 2 over x plus 2. The last one is a little bit more complicated. We're going to take g of 0, figure out that. We're going to take g of 0. So I'll put 0 into the g function. That gives me 5. Now I take 5, put it back into the g function. That's 2 times 5 plus 5 is 15. Now finally I take 15, put it back into the g function again. And that gives me 2 times 15, which is 30, plus 5 is 35. Okay, there you go. Now in the next problem, using the law of sines, we're going to, I got some numbers on my calculator here. I want to get that ready for y'all. The first one, we are going to use the law of sines to find the measure of angle x right here, okay? So the measure of angle x, we will set up the law of sines like this, okay? So the sine of 40 over 5, that's the law of sines ratio, the sine of an angle divided by its opposite side length. So sine of the 40 degrees divided by 5, that ratio there is equal to the sine of this angle divided by 7. So sine of x over 7. So we set up this equation. Oh, sorry, there we go. Wasn't on the screen, excuse me. Anyway, here's our law of sines equation. Sine of 40 over 5 equals sine of x over 7. And we cross multiply to get 7, here we go, 7 times the sine of 40, which divided by 5, all right? And that will equal the sine of x. So I showed you that right here. When you use your calculator for that, you get there. There's 7 sine 40 divided by 5, and that gives you that 0.8999 number. That is the sine of x, all right? It's the sine of the angle. It's not the angle, it's the sine of the angle. To find the angle, we take the inverse sine, okay? So there's the inverse sine of 0.8999, and I got that right here. Here it is. The inverse sine of 0.8999 is 64.14, so I'm rounding down to 64 degrees even, down to the nearest integer, okay? I know it said to round to 2 decimal places, but I'm just keeping the numbers. Here we go. I gotta get my act together here. Sorry about that. I know it says to round to 2 decimal places. I'm just rounding to the nearest integer just to keep the arithmetic simple. So we found that this angle is 64 degrees. That will give us a clue on how to find this third angle here, because all 3 angles add up to 180. So I can do some simple subtraction and figure out that this angle down here is 76. Why do I need that? Well, I'm going to use the law of sines one more time to find the length of this side. So the sine of 76 over y, that's here right here, equals that same ratio, sine of 40 over 5. So here we go with the law of sines again. We're going to cross multiply 5 times the sine of 76, but this time we'll divide it by the sine of 40. And that looks like this, all right? There's 5 sine 76 divided by the sine of 40. And right there, we don't have to do any extra steps. That is our answer for y, 7.5. And I rounded to 2 places here, 7.55. And there's the measure of that side length right there. Okay, so a law of sines exercise there. It's a great little tool. Just be careful and go step by step. All right, a couple of volume problems here. Volume of this rectangular prism, simply multiplying the height times the length times the width, and you get 210 cubic inches for that. Nothing really to that, just multiply all three numbers. The volume of this pyramid here is also pretty straightforward. It's the base area times the height divided by 3, often written like this: 1/3 times the base area times the height. So the base area is found by, since it's a rectangle, it's 13 times 20. All right, that's 260, I guess. 1/3 times that times 24. Well, look what I did here. I did 1/3 times 24. It doesn't matter what order I multiply in, since it's all multiplication. So 1/3 times 24, that's nice because that just equals 8. So now I'm just going to multiply 8 times 13 times 20, and that's 2,080 cubic centimeters, okay? So a little trick on there. If one of these numbers is divisible by 3, I use that 1/3 on that one just to keep the numbers nice and whole and friendly. Anyway, we're going to do a volume of a cylinder right here. And the volume for a cylinder is pi times r squared times the height. Since the radius is 9, that's 9 squared, which is 81. 81 pi times the height of 21, and that gives you 1,701 pi cubic centimeters. Should put that on there. There we go. There's our answer, and with pi in it. All right, so here we're matching some graphs and some polynomial equations. What you have to look at is the degree. We talked about this pretty thoroughly in class today. It seemed like a lot of folks had a pretty good grip on this. Anyway, this is a second degree polynomial, and there are only two of those, this parabola and this parabola. And you can see that the zeros, or the roots, for this parabola are +5 and +1. So that's these two right here. So this is equation A, which must mean that the other second degree polynomial, which is right here. Sorry, I wrote third. That just confused me for a second. That's not a third degree polynomial. That's a second degree polynomial right there. And that's the other parabola, graph D. All right, or equation D goes right here. Okay, this is a fourth degree polynomial, and this is the only fourth degree polynomial graph in the collection. So this is the equation for this graph here, and you can see what our zeros are going to be: -1, -3. So there's -1 and -3, and +2 and +4, and there's +2 and +4. So it matches up with the zeros. Plus, it's the only fourth degree. The other three are all third degree polynomials, so you have to kind of look at their zeros. This one has pretty easy to identify zeros: -2, +3, and +1/2. All right, so +1/2, if you check the scale, would be right there on this x-axis. There's 1, 2, 3, so +3, there's the other one, and -2. So this is this graph is for this equation here, equation number C, or letter C. B has some pretty easy roots to figure out: -2, +1, and +4. So there we go right there. There's equation B graphed out, which leaves graph F right here for this one right here. And this is kind of ornery with the -2/3 and the +5/4 and the +1. Anyway, by elimination, we get that one for graph F, or equation F. Okay, end behavior, kind of following that idea right there, you look at the sign of the leading coefficient to tell whether it's positive or negative, and the degree. This is a 1, 2, 3, fourth degree polynomial, and it is negative, all right, here. So on a fourth degree, or any even degree polynomial, the ends go in the same direction. They either both go up or they both go down. And since this is negative, this one has both ends going down. This is an odd degree polynomial, and it is a positive coefficient. That's really all you need to know. You don't really have to care about any of this other stuff. The leading coefficient is positive, and it's an odd degree because that's the highest exponent is a 5. So it's odd, positive, that means right end up and left end down. Okay? All righty, there you go. If you have any questions, feel free to post them in the forum. Bye-bye.